Hello and good morning. I am Divyansh, and along with my teammates Vincent and Michelle, I am here to present our summer's work on tracking climate change causes and consequences with AI and satellite imagery.
With climate change producing significant impacts to society, such as wildfires and rising sea levels, it is important to inform climate change mitigation and adaptation strategies with evidence for decision making, including the location and characteristics of energy infrastructure and the status of natural resources and the environment. However, existing data are not always geographically complete or sufficiently up to date. Our overarching mission is to enable global automated assessment of energy infrastructure to develop pathways to sustainably address energy needs and climate impacts. To do this, our goal is to develop a technique that can take in text queries and identify corresponding climate relevant objects in remotely sensed data. This will allow researchers to quickly collect valuable information from remotely sensed data, such as location and characteristics of key infrastructure and the impacts on natural resources.
However, there are some challenges to achieve these goals. First, it is difficult to obtain high-resolution remote sensing imagery, and even if we have enough data, it is costly and expensive to label all of the data by hand. Therefore, the traditional supervised learning approach, which is dependent on a lot of label data to train, is not ideal for this project. In addition, it is also costly to train a relevant large-scale AI model from scratch. To solve these challenges, our strategy is to tailor an existing bidirectional text-to-image model by fine-tuning it using our own new dataset.
However, before we can fine-tune and train our model, it is very important that we have high-quality datasets that we can use for the set training. Therefore, over the summer, we compiled 11 million text-image pairs to enhance the artificial intelligence model training process. The text label categories within these images include climate-related features such as airports, power plants, ports, offshore installations, wind turbines, and many more. These images were previously collected Sentinel-2 satellite images and demonstrate global coverage of select climatic features. Here in this example on the slide, you can see two examples of the image label pairing of airports and power plants, along with the distribution of these two features on the world map.
The existing model we have applied is CLIP. This model was published by OpenAI in 2021, enabling bidirectional text-to-image mappings. However, one big shortcoming of the CLIP model is that it performs really bad on climate-related remote sensing images. Therefore, our project focused on fine-tuning the CLIP model. Our goal was for the base model to learn the domain-specific or the climate-specific knowledge by feeding it our own dataset. The advantage of CLIP has is that it can extract implicit information from our text-image pairs when providing the image-text pairs that we created. The end result is a fine-tuned model that can successfully implement the text-image queries against remote sensing data, and it can return the accurate matches between text and images.
In conclusion, we would like to thank our professors and our program manager, along with the Climate Plus program and the Nicholas Institute for Energy, Environment, and Sustainability for all of their support this summer. Thank you very much.